Okay, you can go ahead and start with the review problem. You will want to pause the video to do the review problem, and then you can start it back up when you're ready. Okay, so we want to first find the zeros. Okay, and we can find the zeros by any method that we want to. Personally, when there's nothing out in front of x squared, I like to try factoring. So I would do numbers that multiply to negative 12. So let's do let me change the pen. So let's do zeros over here. So I'm finding numbers that multiply to negative 12 that add to negative 1 in the middle. That'd be 3 and negative 4. So it's x plus 3, x minus 4. Again, nothing in front of the x squared, so I don't need to divide. So I just need to solve these two. X plus 3 could be 0, or x minus 4 could be 0. So x is negative 3, and x is positive 4. So there are my zeros. So those are the numbers that go directly onto the x-axis. So left 1, 2, 3, and right 1, 2, 3, 4. So there are my zeros. Now I'm ready for my vertex. So remember, my vertex is negative b over 2a. That's my x value of the vertex. So x would be negative b. B is negative 1, so negative b would be positive 1 over 2 times a is 1. So it looks like my x value here is 1/2, or 0.5. Then I need a y value to go with that. So y equals 0.5 squared minus 0.5 minus 12. So 0.5 squared would be 0.25. Then I want minus 0.5 minus 12. So 0.25 minus 0.5 would be negative 0.25. Minus 12 more, y would be negative 12.25. So my vertex here, x comma y, is 0.5 comma negative 12.25. So let's go ahead and graph that. So 0.5 would be over a half. Over a half, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my graph only goes down to 10. So I'm just going to drop it off the graph down here, and right here's my negative 12.25. And I can go ahead and make my parabola, and that's my nice review. So so zeros first, vertex second. You should have those 3 points to graph. Okay, so let's look at, obviously this set of notes is called special cases. So let's see what happens here if something weird kind of happens, okay? So approaching the problem, we're not going to know that it's a special case, so I'm just going to do it like I normally would. So I start with zeros. Okay, and again, nothing in front of x squared, so I would go ahead and factor. So I'm finding factors of 9 that add to 6. That'd be 3 and 3. So I have x plus 3 equals 0. So that means x plus 3 could be 0, or same thing, x plus 3 could be 0. Okay, so that means x equals negative 3. So I only have a single 0 this time. Okay, so that's something that's weird that happens. So if I go left 1, 2, 3 on my x-axis, here's my 0. Okay, so what we need to think about here is the fact that my graph is only crossing the x-axis one time. Okay, so if my graph is only crossing the x-axis one time, it is either going to have to be a parabola that just touches the x-axis like this, okay, or it could be upside down, a parabola that just touches the x-axis like this. Either way, we have to know that this point right here is also the vertex. Okay, so this point right here is also the vertex. So unfortunately, if we find the vertex, we're still going to be left with 1 point. And if you remember from last time, I really stressed that in order to graph a quadratic, you have to have 3 points. So I find the 0, it's a -3. If I find the vertex, it's also going to be -3, 0, so it's going to be that same point. So another easy point that we can find is the y-intercept, okay? And the reason a y-intercept is really easy to find is because we know every point on this y-axis, the x value is going to be 0, okay? So I can't find the vertex, so let's instead find the y-intercept. And remember, the y-intercept means x is 0, okay? So let me pull this over so it's not on the, oh, I'm not going to be able to do that. It's being difficult. Hold on, sorry. There, okay. So I'm going to find the y-intercept. Sorry, I just didn't want it on my graph there, which means x is 0. Okay, so I'm just going to use my function up here with an x value of 0. So these two places that I see x's, I'm just going to plug in at 0. So I have y equals 0 squared plus 6 times 0 plus 9. So 0 squared is wiped out, 6 times 0 is wiped out. We get y equals 9. Okay, so I go up on the y-axis, up 9, and there's my y-intercept. Okay, and then we briefly talked last time about something called the axis of symmetry. So the axis of symmetry, symmetry obviously means the same on both sides. So the axis of symmetry on any quadratic always runs through the vertex. So I'm going to just make my dotted line, which represents the axis of symmetry, going through the vertex. So this is the axis of symmetry. Okay, it always runs through the vertex. Symmetrical, again, means same on both sides. So if this y-intercept right here is 1, 2, 3 spaces away from the axis of symmetry, that means I can go 1, 2, 3 spaces on the other side, and there will be my third point. Okay, and then I can draw my quadratic from there, or my parabola from there. Okay, so if your 0, if you only have a single 0, which is the same thing as the vertex, on the x-axis, so if you do your zeros, whether it's factoring or quadratic formula, whatever it is, and you only come up with a single answer here, you know that, hey, that's my vertex. Okay, it's both my 0 and my vertex. So instead of finding the vertex and wasting your time doing that, finding the same point again, you go to the y-intercept where x is 0. So solve it down and find your y-intercept, and then just reflect it over the axis of symmetry. And the axis of symmetry always goes through the vertex. Okay, so go ahead and pause the video and do the try this. Okay, so working through this, so I find my zeros. Nothing in front of x squared, so I'm going to factor. So factors of 4, that to -4, that'd be -2 and -2. So I have x minus 2 equals 0. So x minus 2 could be 0, or x minus 2 could be 0. It's going to be the same thing both times. So x equals +2. So we know we have a special case because we only have a single 0. So let's go ahead and graph that. X equals +2. Okay, so that's both my 0 and my vertex because there's only one of them. If there were 2 zeros, I could go ahead and find my vertex like normal, but since there's only one, I know that has to be my vertex. So instead of finding vertex now, I'm going to find the y-intercept, which means x is 0. Okay, so I plug a 0 in for x, so y equals 0 squared minus 4 times 0 plus 4. So my y-intercept here is 4. So I go up 1, 2, 3, 4 on the y-axis. Okay, and then I can draw in my axis of symmetry, right? Here's my axis of symmetry that goes through the vertex. And since this point here, this y-intercept here is 1, 2 spaces away from the axis of symmetry, I go 1, 2 on the other side, and there's my third point. Sorry for the color change there. Oh well. Okay, so there's my parabola. Okay, so that's special cases. Okay, so the special case happens when you only have a single zero, and you kind of have to be a little creative about the other 2 points you can find. Okay, let's go ahead to the next page and look at parent graphs. Okay, so for parent graphs here, you will need Desmos. Okay, we've done this before with exponential functions, but you will need Desmos. To start off, I'm just going to tell you about A. We're not actually going to do anything. I don't think. Nope, we just have the 2. So we're not going to actually do anything with A. Really, all we need to know about A is that positive A, okay, makes my parabola open upward. A negative A makes my parabola open downward. Okay, that's the only thing we're going to learn about A. A does shrink and stretch and compress your parabola based on how big it is and different things like that, but we're not going to get into much of that here in Algebra 1. Okay, so let's go ahead and discover what the H and K values are. Okay, so let's go down to problem 1. So what you're going to do is pause the video. Once you pause the video, you will want to go to Desmos, and I want you guys to graph these 3 functions. Okay, once you graph these 3 functions, go ahead and sketch them over here, and then we'll talk about what this H value back here does. Okay, so go ahead and pause the video, and then you can start it up when you're ready. Okay, so y equals x squared is just going to be a nice little, oops, I missed. Okay, so A is just going to be a nice basic parabola. Once we throw in the -3, it's going to shift over this way. Okay, and then once we throw in the +2, it's going to shift over this way. Okay, and hopefully in your conversations, what do you think the H value does? It's going to shift it horizontally. Okay, so let me zoom in here. So H shifts horizontally. Okay, and it's going to be the opposite of what you may think. Okay, so the -3 on B actually shifted it to the right, so negative, oops, moves right, a positive moves left. Okay, so it's a horizontal shift, and it's the opposite direction of what you may think. So let's go up here to H. Okay, and we're going to say horizontal shift. And this way is going to be positive. This way is going to be negative. Okay, left is positive. Right is negative. Okay, now let's go ahead down to question 2 or problem 2, and we're going to do the same thing. So go ahead and pause the video, graph the 3 on Desmos, sketch your graphs over to the graph on the right, and then go ahead and talk with your group about what you think the K value does. And then when you're ready, you can go ahead and unpause the video. Okay, so my x squared, again, is just the regular old graph right here. Once I do the +3, it's going to go up here. I missed a little bit, but it's supposed to go right here, yeah. And then the -1 is going to put it right down there. Sorry, I shouldn't move it out any. Okay, so all the K value does is it's going to move it vertically, and it's going to go the exact way you would think. So K shifts vertically. and it's going to be the way that you think. So negative moves down, positive moves up. Okay, so let's go ahead and fill that in up here. So for my K value, that is a vertical shift. Okay. And positive is going to move it up. Negative is going to move it down. Okay. So let's just practice really quick down at the bottom. Just pull it down to the bottom. We're going to do just a couple examples. So say we had y equals x plus 5 squared plus 10. Okay. The plus 5 in the middle right there is going to tell you left 5. The plus 10 right there is going to tell you up 10. So this would be your answer, left 5, up 10. Okay. The second example with the opposites. So say we had y equals x minus 2 squared minus 8. This minus 2 right there would tell you right 2. That minus 8 right there would tell you down 8. And that would be your answer. Okay. So we did this with exponential functions. Hopefully some of that's ringing a bell. They obviously look a little bit different because these are quadratic functions rather than exponential functions, but the same type of deal. Inside the parentheses is opposite. Outside the parentheses at the end is going to be exactly what you would think. So those are the notes.